Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 18th, 2025, about 2 days ago. The striking result is that strategic competition among multiple misaligned agents can deliver outcomes close to a perfectly aligned model when the user's preferences sit approximately in the convex hull of the agent's utilities. The paper is titled Emergent Alignment via Competition, and as we'll see later, the implications for deployment and governance are quite significant. Beyond the core theory, the work offers guarantees for bounded rational users and shows empirically that adding diverse agents improves alignment quality through convex combinations. On X, a researcher highlights the central claim: multiple imperfect agents in competition can deliver aligned outcomes without solving alignment outright, because users can choose among them. The post links the preprint and frames the convex hull idea as the key insight. Engagement appears moderate, with roughly 80 likes and a few replies. Alright, the previous segment summarized the setup for ethics and movie lens. Figure 1 shows how alignment error drops as the number of bobs increases, which supports the convex hull idea. The green and red curves for non-negative least squares and simplex beat both the best single bob in blue and the naive average in orange. The left panel shows about 50% reduction on ethics by 100 agents, while the right panel shows roughly 70% on movie lens. So the previous figure showed large airdrops with more bobs. Figure 2 presents sparsity, which means how many agents actually get non-zero weight in the best combination. The left ethics panel rises to about 18 active agents by 100, while the right movie lens panel reaches roughly 26. NNLS stays slightly sparser than simplex, so the method concentrates weight on a smaller, more informative subset, which supports the idea that only a few diverse biases are needed for strong alignment. Well, the previous figure contrasted worst-case equilibria with theory. Figure 4 shows the utility that actually emerges under best response dynamics versus misalignment, which means how far Alice's preferences sit from a non-negative mix of the bobs, utilities. The panels for synthetic 1, synthetic 2, and movie lens all slope downward as misalignment grows, so lower misalignment predicts higher utility. Outline markers indicate the minimum over equilibria, and solid markers indicate the best response outcome, which often sits noticeably higher. Alright, the previous figure compared best response outcomes with the worst case. Figure 3 shows minimum Alice utility in Nash equilibrium versus misalignment, which measures how far Alice's preferences sit from a non-negative mix of the bobs, utilities. The dashed red line gives the theoretical bound, opt minus 2 epsilon, while the dotted green line marks Alice optimal utility. Across synthetic 1, synthetic 2, and movie lens, points sit above the red bound and trend downward as misalignment grows, so smaller epsilon reliably yields higher guaranteed utility. Wrapping up, 2 takeaways stand out. Competition among diverse, imperfect agents can deliver near-aligned outcomes when a user's preferences lie close to a non-negative mix of agent utilities, and adding diversity reliably improves results, both in theory and in simulations. The broader implication is a market design path for alignment. That is it for the AI Research Roundup. I am Alex. Thanks for listening.